So I'm going to take a quick break from ratios and proportions. I was supposed to do a couple of those today. I had someone contact me about an issue that they were having with one of their kids. So today I'm going to do a quick one on solving systems of linear equations. All right, so systems of equations. Just going to give you some basic facts. So no matter how you approach this problem, no matter how these problems are presented to you, this is the first main thing right here. When we're talking about a system of equations, we're dealing with something that has more than one equation. All right, so that's number one. More than one equation is when we're talking about that system of equations. There's only three possible outcomes. That's it. I don't care how many types of problems you are given. Only three things could possibly happen, and that is it. Either you're going to have an intersection, which gives you one solution at the intersection, or you're going to have no intersection, that's no solution, parallel lines, or you're going to have infinite solutions, right? That means both equations or all the equations happen to be the same equation, all right? So if you're dealing with two equations and after you simplify them or whatever and they end up being the same thing, that's an infinite solution. You have two different equations and they never intersect each other, that's no solution. If you have two equations, they happen to intersect each other, that is one solution. Those are the only three possible outcomes. So there's two ways that we solve these types of problems, systems of linear equations. Either we're going to substitute or we will be using what we call the elimination method. I prefer the elimination method for pretty much all of them, but there are times where substitution is a better route. So I will do one of each. I might do two of the elimination and one of the substitution. So just pay attention to how it goes. I'm going to actually work with the same problem so that you see how both techniques work on the same problem. All right, so this one right here is just going to be a way that you can apply what we call the elimination method. I'm going to do elimination method first. It works every single time if you kind of stick to what I'm saying. You got to stick to what I'm saying and it'll work every single time. All right, so we're going to solve this system of linear equations. I hope you get a good look at it, right? It says 2x plus 4y is equal to 12. Then right below it, we have x plus y is equal to 2. All right. You want those coefficients shown. If there's coefficients not written, fill them in with the number 1 if need be. But we're going to have all the numbers showing so that you can see them. That's number 1. And what you're looking at is standard form. Remember, I said standard form is key. Standard form is when you have your variables on one side in alphabetical order and you have your constants on the other side. All right. Variables on one side, constants on the other side. That's what you have to do before we do elimination. All right. So what we do is we take these leading coefficients and we switch places. All right. This leading coefficient is a 1, we move that up. This leading coefficient is 2, we move that down. So these coefficients are going to flip-flop, if that's a word or a term, right? We're going to flip-flop those. The other thing is you don't want these to wind up having the same sign when you're done multiplying. So since both of these are positive, I'm going to just make one of them a negative, all right? And you'll see why on the next step. So when you multiply everything times 1 across the top, nothing happens, right? That's what happens when you multiply by 1. But when you multiply everything by a negative 2 at the bottom, what you get is a negative 2x, right? Multiply that, you get a negative 2x. You multiply these, you get a negative 2y. And if you multiply those, you get a negative 4. So all you're doing is writing down your results as you multiply on your new lines, all right? So the reason why I did the thing up here where I had to flip the signs and everything is because what I'm forcing to happen is I'm forcing these to become opposites of each other. That's all you want to happen. You want these to be opposites of each other because what happens when you total this out? It really becomes a 0. Instead of writing 0, we just strike it out, all right? It's gone. So what we do is we just go column by column and calculate now. 4 minus 2 is 2, so that's why I have a 2y. 12 minus 4 is 8. That's why I have an equals 8. You can divide both of these by 2. Oh, goodness, I cannot write. And that means y is equal to 4. So we found our first coordinate. y coordinate, not whole coordinate, y coordinate. We still got to go back and find x. So I'm looking at one of the original equations, either the one at the top or this one at the bottom. I'm going to go for the one that looks the easiest to work with, right? Which is the x plus y is equal to 2. That's the easiest one to work with. Now I'm going to go back to what I have here, y is equal to 4, and transfer it here. All right, so you see how I did that? So y is equal to 4. Then I can solve for x. So x is equal to a -2. So now that I know what both variables are, basically my final answer, or most of the time, you're asked to put this back in a coordinate form. Your solution is -2, 4, because you have to put your x first and your y last. That's your solution. All right, for any parents out there or anybody that's trying to learn how to do this or at least verify your work, I do recommend downloading this, GeoGebra Classic 5. That's what I'm using. I use this software a lot. It gives you graphs. It's all sorts of things that it can do. What I'm going to do is take what we just did on the board and graph it out. So my first equation, the one that said 2x plus 4y is equal to 12, that one, that's what this black line is right here. The other one, the x plus y is equal to 2. That's this other one right here. And if you notice, they do intersect somewhere. Remember, there's only 3 things that could possibly happen: an intersection, no intersection, or infinite, right? This is the one that represents one solution because we see one intersection. All right, so what I'm going to do is come up here and find out where they intersect. Okay, so they intersect. There we go. So if I do this and then I intersect it with that, see, it gives me a point called A. And if I look at point A, that's the same 2 numbers that we got on the board, -2, +4. So yes, what we found was the solution, and our solution was correct. All right, our solution was correct. All right, second example using substitution. When you read your problems and you read the instructions, make sure you understand what they say. Sometimes your instructions tell you which method they want you to use. All right, so always make sure you follow that. If the instructions do not tell you which method to use and you're free to use whichever method you want, my key piece of advice will be master one of them and roll with that one every single time. All right. Right now, I'm going to show you how to approach a substitution, or at least point out when it might be a good idea to use substitution. So right here, you have a problem on the top, which is in standard form. When your variables are on the same side together and your constant is over here by itself, standard form. You got it? Down here, this one is not in standard form. This one has a single variable being equal to an expression. All right. Normally, it's a problem like this that is indicating it might be best to use substitution. All right, so substitution is not hard. This is telling you where the substitution should go into the other problem, all right? So in other words, if I know y is equal to all of this in that box, then guess what I'm going to replace this with? I'm going to replace this one with whatever this box says and stick it into that box, because anytime things are equivalent to each other, they're now interchangeable, all right? So that's what we're going to do. We're going to substitute all of this right there where that y was. Once I make the substitution, remember it said 2x plus y. It said 2x plus y earlier, but now y becomes a 2x minus 1 because of substitution. And then it's still equal to 5. So basically, I just did the problem. This type of problem does require you to be very good at simplifying and combining like terms. So if you have a problem with simplifying and combining like terms, I would suggest that you stop and go back and tighten up on those first, because without that, this is not going to help. All right, so I'm going to move forward. I'm going to add those two together, and that's a 4x. That's a -1, and that's an equals 5. All I have to do is add 1 to both sides. If I add 1 over here, I get a 6. So I'm going to write a 6 and bring down my 4x. Then I'm going to divide 2 on, and that 2, I'm going to divide by 4 on both sides. So x is equal to, and then I'm going to simplify that to 3/2. All right, so I got my first value, 3/2. Y is equal to 2x minus 1. That's from the original problem. This is also going to be the one that we have to use to figure out what y is equal to. And since we have our other value, x, all we have to do is put our value for x right there. And remember, that value is 3/2. So this one actually isn't bad. I know when some of you see that fraction for the previous value we found, you automatically go into a bad space, right? It doesn't matter. If you know you did your math correct, keep rolling with it, all right? Just keep rolling with it. If you make a mistake, that's fine, but just keep rolling with it. Do not change your game in the ninth inning. Does everybody understand that? All right, so here we go. Plug in my 3/2. Just so happen that happens, and now I have a 3 minus 1. The answer is 2. So guess what? Y is equal to 2. X is equal to 3/2. Y is equal to 2. That means my final answer is going to be written like this. X is 3/2. Y is 2. Problem is solved. Here I go again. I'm using my handy software, right? Y is equal to 2x minus 1. I also have a 2x plus y is equal to 5. These are the two equations that I was just dealing with. I'm also looking at their intersection. So based on this alone, I already know there's a solution because there's an intersection. There's the dot, and I'm going to find out what the value is. So let me see. And look what we have here. There's my dot. It's point A. I don't know if you can see that, but look at that. 1.5, comma 2. Guess what 3/2 is equal to? 1.5. So yes, we have the correct answer, and we have verified it. All right, it has been verified. So don't forget, you have 3 possible outcomes: 1 solution, no solution, infinite solutions. All right, that's when you're dealing with system of linear equations. And then you have 2 techniques that we really kind of rely on. Either we're going to be eliminating or we're going to be substituting. I am all for elimination, but that's me. All right, so find out or practice each one, and the one that feels most comfortable to you, definitely make sure you master that one. All right, make sure you master at least one of them so that you just won't be lost altogether. All right, so those are your 2 right there.